Hi, good evening. We are from G5. I'm NG, and my other team member consists of Ching Yi, Jackie, Terence, and Kian Yong. And today we'll be talking about Graphic Processing Unit, in short, GPU. So for the presentation, we'll first go through what is GPU about, the comparison between GPU and CPU, the pros and cons of GPU, and our conclusion. So what is Graphic Processing Unit? GPU is a computer chip that perform rapid mathematical calculations, primarily for the purpose of rendering graphics such as financial modeling and scientific research, animation, and the video for the computer screen. And it is also a single chip processor primarily used to manage and boost the performance of video and graphics. So the feature of GPU include 2D or 3D graphic, texture mapping, app support for high intensity graphics such as auto CAD. And in the early days of computing, the central processing unit CPU actually performed this rapid mathematical calculation. However, as more graphic-intensive applications such as auto CAD were developed, which degraded the CPU performance. As this application required high demand on the CPU, this is because auto CAD is a computer-aided graphing software application that is used to create blueprints for buildings, bridges, and computer chips. And this performance actually demands a lot of processing power from the CPU. Therefore, GPU came about as a way to offload these tasks from CPU and free up their processing power. Now I'll pass on the time to Jingyi to talk about the comparison between CPU and GPU.
The CPU has often been called the brains of the PC, but increasingly that brain has been enhanced by another part of the PC, which is the GPU. So what's the difference between CPU and GPU? CPUs have a larger instruction set so that it can perform a wider range of tasks. A GPU can only do a fraction of what the CPU can do, however, it does so with more speed and is more powerful and cost efficient than the CPU. The CPU consists of only a few cores, whereas in the GPU, it's composed of over 100 cores to process thousands of threads and accelerating some software by over 100 times more quickly than a CPU alone. And it helps to make time-sensitive calculations for 1000 pixels at a time, making it possible to display complex 3D graphics. Next, it's able to handle few software threads at a time for sequential serial processing for CPU, while in GPU, it's more on parallel multi-threaded and has many cores processor. The CPU is best at handling single calculations extremely fast, whereas in the GPU, it's better at handling multiple different calculations. Next. So some forms of GPU applications are beyond just simply rendering graphics, but also in like financial modeling and scientific research, etc. It is not only used in video card or motherboard, but also in mobile devices, display adapters, workstations, or even game consoles. They also play a huge role in accelerating applications in platforms ranging from artificial intelligence in cars, for example, or drones or even robots. Next, we'll show you a video on the comparison between the speeds of GPU and CPU.
All right, I introduced to you Leonardo, and he's going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1. Let me speed it up. Ladies and gentlemen,
Leonardo 2.0.
When we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target. Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration.
Yep.
In 10,
9,
8, 7, 6, 5, 4, 3, 2, 1.
Ladies and gentlemen, science class is now over.
Thanks, Chingy. Now I'll talk about the benefits of GPU. Firstly, GPU render graphics quickly. It's able to process parallel streams of data simultaneously. By doing so, it allows applications to run in parallel. This can be used to drive high-performance applications that require high processing computing, such as Photoshop, data encryption, to intensive gaming applications. With the rise of AI, as mentioned by Chingy, a normal deep learning technology requires days to weeks. With the use of GPU, the process of deep learning is able to reduce to a few minutes only. Now I'll pass the time to Terence.
Okay, so thank you, Jackie. So next I'll talk about the limitations. There's 4 limitations here. The first is that GPU is not efficient for serial tasks. So GPU are more efficient than CPU only when they are handling parallel loads. So for serial tasks or sequential process that requires the computation, the output by the previous computation, the number of cores will not affect the performance. Instead, right, GPU with a much slower clock speed may deprove the performance. So the next limitation is it is slow to process complex operation on few data streams. So a GPU can handle large amounts of data in many streams, performing relatively simple operations on them, but they are not suitable to do complex operations on like a single or a few streams of data. Next will be the compatibility of the modern operating system. So GPU are not compatible with the predominant x86 instruction set, unlike CPU processor. GPU cores are designed to handle very proprietary instruction sets that may change significantly with every hardware generation. So GPUs require different programming language to modify programs to suit the architecture. Hence, several features are missing from GPUs, and they include interrupts and virtual memory required to implement a modern operating system. So lastly, as GPU operates in a separate memory space with totally different instruction sets, the processing codes have to be offloaded from CPU to GPU. So if the problem is greater than the amount of RAM on the GPU, the performance will drop significantly. So transferring over the PCIe protocol, which means peripheral component interconnect express protocol, will lower the speed 20-fold compared to onboard memory. So next we will walk through like some sample codes that we have found. So this is sample code that we're going to run on CPU first. And as we know, right, GPU actually works more efficient when handling like large volume of data when handling simple operation. So first we're going to run this piece of code on the CPU. So explaining what this code is about. First, we will have 3 arrays here, array A, B, and C. And each array actually contains like a large number of elements. And so a simple operation will involve adding the elements in each array. So from here, C equals to A plus B. And then we also include like the timer to record the amount of time that's taken to compute the whole operation. Yep. So so if we were to run this code, this will be the amount of time that is taken to run on the CPU. And next, we're going to look at what happens if we run on a GPU. So to run on a GPU, we actually use this CUDA toolkit to help us to run this piece of code on the GPU itself. And as you can see, we have imported this library, and the code will remains the same, but now at this the only difference is that this piece of code is run on the GPU. So let's run this code, and as you can see, there's a significant difference of the timing. First, when we run the same code on the CPU, we are using about 11 seconds, and now we are using like less than 1 second itself. So this is the sample code that we have found. that actually demonstrate how efficient GPU is when handling simple operations on large data volume. Okay, so next, Kenyon will help us to conclude the presentation.
Okay, so to conclude the presentation, so one of the points is that CPU acts as the brain of the computer, optimizing serial processing. So CPU in terms of the difference between CPU and GPU is that CPU is able to take in a larger instruction set, therefore they can perform a wider range of tasks. And CPU is also able to run at a maximum clock speed and capable of managing the input and output of all of a computer's components. Whereas for GPU, it optimizes more of the parallel processing with more cores on the graphic cards. And GPU is actually also very specialized. It can do the tasks that CPU is able to do, but is in a much faster in a much faster process as it complements the CPU's processors. So all in all, the most ideal situation is when CPU and GPU are being used to provide a more efficient and powerful computer. So with that, we end our presentation. Thank you.